Welcome to all in this lecture. This is the second video in the series of beam. In this video, we are going to study the support of the beam and its type. So let's start. So support of a beam. Support of a beam is a construction which exerts force acting in any direction, preventing translational motion, relative displacements of any end of the beam, but cannot prevent rotational movement. Okay, so consider this is a beam. So consider this is a beam and these are two supports holding the beam. These two supports give a reaction force in the perpendicular direction opposite to the beam. Okay, these are the forces exerted by the supports, and these two supports don't allow any translational motion, not any relative displacements, because these are holding the beam. The beam cannot move in this direction, nor downward nor upward. Okay, and also, but the supports cannot prevent the rotational motion. A beam gives rotational motion, but how, we will see in this lecture in the further slides. So let's start. Now let's study the types of the support. The first type is the simple support. In this type, the beam is supported by a column. Okay, see here, this is the beam supported one side from a wall and on the other side by a column. This column give a reaction R in a perpendicular direction, that is in the 90 degree with the beam. This is the first type, and in the free body diagram we are going to show the simple support by this notation. Okay, so let's move forward. What is meant by the roller support? This is the second type of the support, the roller support. So beam is supported by a simple roller. See here, the beam is supported by a simple roller here. Okay, and what does it look like? It looks like a reaction R in the perpendicular direction, same as the simple support. Its free body diagram is same as the simple support, and it gives only one reaction perpendicular to the beam. So there is another way of illustration of the roller supports. If this is the beam, we can show a triangle. We will show two wheels below the triangle and a rigid plane below it. You can show this as this construction also. So now these are two constructions of the roller support. See here, this is a beam and the roller support is at a inclined rigid plane, so the reaction force R will be perpendicular to the rigid plane. It will not perpendicular to the beam. It will not be perpendicular to the beam, but it will be perpendicular to the rigid plane. Okay, so let's move forward. So there is a concept known as the hinge or the pinned support. So here the beam is supported by a hinge joint. Hinge joint, we know where his hinge joint used in the doors. Mainly the hinge joint is used in the doors. Okay, so this is the hinge joint. This is a column supporting the beam, and this is our beam. Okay, so it gives two reaction forces. Okay, one reaction force is in the same horizontal direction of the beam. Okay, if this is the beam, then the reaction force will be in this direction. Let's call it RH. See here, RH in this direction, and the other reaction force is developed perpendicular to the beam. See here is the RH force and it is the RV force. RH is in this direction and RV is in the perpendicularly upward direction to the beam. So if we use RH and RV to find a resultant, the resultant will be R. So we are composing these two forces and finding the resultant R. So what will be the formula of R? R is equal to under root of RH square plus RV square. From this expression we can find the magnitude of R, and for the direction of the R we will use alpha. If alpha is the angle with the horizontal x-axis, alpha is angle with the horizontal axis or the angle with the beam. If the beam is horizontal, then alpha is equal to tan inverse of RV upon RH. RV upon RH. Okay. These are the two formulas which you will need to find the resultant R. Now let's move forward. This is the last type of the support. It is known as the fixed support. Beam is a projection supported by wall. What does the line means? That is, a small part of the beam is embedded inside the wall. That is, the beam acts as a projection supported by the wall. And if this is the beam, then the beam will move in downward direction due to the self weight. So it will create a clockwise moment. What it will create? It will create a clockwise movement. It will be creating a rotation. It will be creating a rotation. This is how a beam can create a rotation. So in a clockwise direction it will create a moment. So to cancel this movement, to cancel this clockwise movement, a anti-clockwise movement is developed at this point, or is developed at the wall portion of the beam. See here, a moment MR is created at the starting point of the beam, or at the embedded portion of the wall, and other two reactions are also developed. One is RH in the direction of beam, and a reaction RV perpendicular to the beam, perpendicularly upwards. And we can also find a resultant R of RH and RV. How will we find? In the last slide we saw R is equal to under root of RH square plus RV square, and angle alpha, which angle alpha? This angle alpha is equal to tan inverse of RV upon RH. Okay. And now a last point, there are certain symbols which are given in the question to show various supports. So let's see first this symbol. In this symbol, here is a beam and here is a triangle on a rigid plane. So this is the symbol of simple support. This is the symbol of simple support. See here. Now this symbol has a triangle and below there are two rollers on a rigid plane. So this symbol is of a roller support. Now see here. This is a new type of a symbol. There is a roller here. On that there is a triangle. On below there are two wheels and then the rigid plane. So this symbol is of a hinge support. And now the last symbol, this symbol. Here a part of the beam is attached to a rigid plane, or we can say it is attached to a wall. And when a beam is attached to a wall, we call it as a fixed support. Okay, these are the four symbols. Let's revise. This is the simple support, this is the roller support, this is the hinge support, and last this is the fixed support. Okay, that's all for this lecture. In the next video we are going to see the types of loads and what does the loads means. So thank you.